Let's find the second derivative of the function y equals x to the fifth plus 7. So first we need to find the first derivative, which is dy dx. Using the power rule, looks like 5x to the fourth. Now the second derivative then using the power rule is going to be 20x cubed. So to find the second derivative, we're taking the derivative of the first derivative. For part B, we have y equals 3x squared plus 6x minus 7. To find the second derivative, we begin by taking the first derivative, dy dx. So using the power rule, we have 6x plus 6 is the first derivative. Now take the derivative of that to find the second derivative, and we have that the second derivative is just 6. Once again, we're asked to find the second derivative. Our function this time is the quantity x cubed plus 2x, all raised to the 6th power. So we begin by taking the first derivative. So here we're going to be using the chain rule. We're bringing the 6 out in front, mentally blocking out what's inside those parentheses, and then subtracting 1 from the exponent to give us an exponent of 5. Now we need to take the derivative of what's inside the parentheses. So now we need to take the derivative of the x cubed plus 2x. So the derivative of that is a 3x squared plus 2. So there's our first derivative. Now we need to take the derivative of this to get our second derivative. Notice here we have a product. So we're going to be using the product rule. So I'm going to label the first one here as f and the second here as g. So the product rule says we do f g prime plus g f prime. So our second derivative then is going to look like 6 times x cubed plus 2x to the fifth. So I'm just copying down the first one there. Now times g prime, so take the derivative of the second. So the derivative of 3x squared plus 2 is a 6x. Now plus g, so we have a 3x squared plus 2 times f prime. So using the chain rule to find the derivative, we're going to bring the 5 out in front, so we're going to really have a 30, and then mentally blocking out what's inside the parentheses there, the x cubed plus 2x. Subtract 1 from the exponent to give us a 4. Now we need to take the derivative of what's inside the function. So that's going to be 3x squared plus 2. Okay, so now let's simplify. We've got common factors that we can factor out. We can factor out a 6, and we can also factor out an x cubed plus 2x to the fourth. Okay, so what are we left with then? So we factored out the 6, so we still have a 6x and then an x cubed plus 2x left in the first term. In the second term, we're left with a 5 because we factored 6 out of the 30, so we have a 5 left. We also have 3x squared plus 2, and we have 2 of those. All right. So now let's simplify what's inside the brackets here. We still have the 6x cubed plus 2x to the fourth. Distributing the 6x through, we have 6x to the fourth plus 12x squared plus a 5 times, and when we multiply this out, we're going to have 9x to the fourth plus 12x squared plus 4. Alright, so now we have 6 times x cubed plus 2x to the fourth, and then we have 6x to the fourth plus 12x squared. Distributing the 5 through gives us 45x to the fourth plus 60x squared plus 20. Okay, so now let's combine like terms within the brackets here, and we have a 6 times x cubed plus 2x to the fourth times a 6x to the fourth plus 45x to the fourth. It's going to give us a 51x to the fourth. Now combine the x squared terms. We have a 12x squared and a 60x squared to give us a 72x squared. Now combined, and then we're left with a 20. And there is our second derivative. Now we're asked to find y double prime. Once again, we're finding the second derivative. So we're going to begin by first finding the first derivative, y prime. Using the power rule, we bring the 2/3 out front, subtract 1 from the exponent to give us a negative 1/3 exponent. And then the next term, derivative of 4x, is 4. So now we're going to find the second derivative, also using the power rule. Bring the negative 1/3 out front, so we have a negative 2/9x to the subtract 1 from the exponent. We have a negative 4/3. And then, of course, the derivative of 4 is just 0. We're also finding the second derivative with y equal to 2x plus 3 in the numerator, all divided by 5x minus 1 in the denominator. Notice here we have a quotient, so we're going to have to use the quotient rule to find the derivative. So I'm going to label the top with an N and the bottom with a D for numerator and denominator. Remember what the quotient rule looks like. The quotient rule looks like the denominator times the derivative of the numerator minus numerator times the derivative of the denominator all over denominator squared. So then y prime, we begin by taking the denominator, which is 5x minus 1, times the derivative of the numerator. Well, the derivative of the numerator is a 2. And then minus the numerator, which is 2x plus 3, times the derivative of the denominator, which is a 5. All divided by denominator squared, 5x minus 1 squared. So now let's simplify. Distributing the 2 through, we have a 10x minus 2, and then distributing the 5 through, we have a minus 10x minus 15, all divided by the 5x minus 1 squared. So notice how the 10x and the negative 10x cancel. So y prime then, we are left with a negative 17 divided by 5x minus 1 quantity squared. So now that we have y prime, we can take the derivative of y prime to get the second derivative. I'm going to rewrite y prime as a negative 17 times the 5x minus 1 to a negative 2. By bringing the denominator to the numerator and making the exponent negative, I can now use the power rule to take the derivative. So y prime then is going to look like, bringing the negative 2 out in front, a negative 17 times a negative 2 is going to give us a positive 34. Mentally blocking out what's inside the parentheses there. Subtracting 1 from the exponent gives us a negative 3. Now we need to multiply by what's inside the parentheses. So take the derivative of what's inside the parentheses, which is 5. So now simplifying, 34 times 5 gives us 170 times 5x minus 1 to the negative 3. Or we could write y double prime as 170 over a 5x minus 1 to the third power. And there is our second derivative, y double prime.